let's look at the powers of I and see the pattern. So I to the first power will give us I to the second power it will give us -1, I to the third power will give us -I, and I to the fourth power will give us 1. I to the fifth power can be broken up to I to the third and I to the second, which is -1 times -I, which is just I. And then I to the sixth power is I to the fifth and I to the first, so I times I, which is I squared, which is -1. And then I to the seventh power is 6 and 1, so -1 times I, which is -I. And then I to the eighth power is 7 and 1, so -I times I is -I squared, which is -1, which is +1. And then we have I to the ninth power, which is 8 and 1, which is 1 times I, which is I. So if you notice, a pattern starts to develop. You have I, -1, -I, 1. I, -1, -I, 1. So this pattern is going to keep on repeating over and over and over again. So because of that, we have a way to figure out how to simplify any power. You could do any power of I and simplify it, because it's always going to be one of these four choices. It's either going to be I, -1, -I, or 1. It has to be one of those. It's always going to simplify to one of those. So since there are four choices, we will divide our exponent by 4. Okay, so to simplify an imaginary expression with a large exponent, we want to divide the exponent by 4. Okay, so let's do an example. Let's do I to the 57th power. Okay, so we're going to divide 57 by 4. Okay, so we get 14 with a remainder of 1. Okay, so that means that we have four times 14, right? So 4 times 14. All right, we have I to the 4 times 14. But then we also have this +1 right here, right? Okay, so this I to the 4 to the 14th, well, we know that I to the 4th is 1. So this is just going to cancel out and become 1. And so the only important number is your remainder. You have a remainder of 1. So the only thing you're really looking at is I to whatever the remainder is. So if your remainder is 1, that means you have I to the first power, which is just I. All right, let's look at another definition. We're going to look at the definition of a pure imaginary number. Okay, which is just the product, which means multiply, right? Product of a real number and I. Okay, so it's written in the form AI, where A is a real number and then I is the imaginary unit. So A is a real number and I is the imaginary unit. Okay, so some example of pure imaginary numbers would be -3i, the square root of 5i, 5/2 I. Notice that -3, square root of 5, and 5/2, those are the real numbers where the I is the imaginary unit. Okay. Also, you can just have I by itself. That's also a pure imaginary number. And you're like, well, what's the A value? Well, the A value is that invisible 1, right? A would be 1. All right, so let's talk about how to simplify radical expressions that have negative numbers. Because we said anytime you have a negative in your radical, you can't leave it like that. You have to simplify it. So let's say we have the square root of negative 32. So this is not the square root of negative 1, because that would just be I. This is the square root of negative 32. However, we know that the square root of negative 32 is the same as saying the square root of 32 times the square root of negative 1, okay? Which means that this square root of negative 1 is I. So we have the square root of 32, I. Okay, however, if it says to simplify, we're not quite done, because 32 can be broken down into 4 times 8. Okay, so what's the square root of 4? 2. So we've got 2 square root of 8i. Okay, so now we think, can 8 be broken down? Yes, it can. So 8 can be broken down into 2 and 4. And the square root of 4 is 2. So now we have 2 times 2, square root of 2. And then 2 times 2 is 4, square root of 2. And 2 can't be broken down, so we are done. This is our final answer, simplified. All right, so let me show you a not really a complicated question, but a question where you might get tricked. So for example, if you have the square root of negative 2 times the square root of negative 3. Now, if you were in the real number system, you could say, well, you multiply these two numbers. So that's the square root of 6. But we're not in the real number system. These are imaginary numbers because they have the negative 2 and negative 3 inside the radical. So you first have to replace them with your imaginary unit. So the square root of negative 2 will be rewritten as the square root of 2i. And the square root of negative 3 will be rewritten as the square root of 3i. Okay? So once you have that done, then you can multiply your radicals. The square root of 2 times the square root of 3 is the square root of 6. But then I times I is I squared. And remember, I squared is negative 1, so you have negative square root of 6. All right, let's talk about solving quadratics that get us imaginary numbers. We're going to do this x squared plus 45 equals 0. So to solve this, we want to isolate x, right? So x squared is equal to negative 45. So we square root both sides. So x is equal to plus or minus the square root of negative 45. Right there we have a imaginary number, right? So we are now in the complex number system, which means that we need to simplify this. So we're going to go ahead and pull out the I. So x is equal to plus or minus square root of 45i. Okay, and then can 45 break down? Let's see. 9 times 5, right? So x is equal to plus or minus the square root of 9 times 5i. The square root of 9 is 3, so x is equal to plus or minus 3 square root of 5i. And then there is our answer. Okay, that's all I have for you today. Go ahead and try 2 through 6.